All right, in this section we're going to be looking at simplifying, multiplying, and dividing rational expressions, starting with just simplifying a fraction. All right, so one of the things that we can do when simplifying a fraction is just to simply prime factor everything. Okay, now in this particular situation we're looking at a fraction where there is no addition or subtraction in this. So this is not a polynomial, this is a monomial. So with this, 45 breaks down into 9 times 5, so that would be 3 times 3 times 5. Got a couple of x's here. Then your denominator factors down to 5 times x. And then we can cancel like factors. So we got an x and a 5 that are going to cancel out, which will leave us with a final answer of 9x over 5. Now, in that particular problem, we had no addition or subtraction in here, so we just prime factored everything. The next problem has addition or subtraction in here, subtraction in particular, and so we factored this using our rules for factoring polynomials. And the first rule for factoring polynomial is to take out a GCF if possible. And so in the numerator, we can factor out a 5v, which will leave us with v minus 1. Now, if we notice in our denominator, we have 1 minus v. Well, 1 minus v here and a v minus 1, those are exact opposites of each other. If they're exact opposites of each other, I can factor out a negative 1, and then they're going to be exactly the same. Because if you factor a negative away from this, that becomes a positive v. And factor a negative out of this positive 1, it becomes a negative 1. Now your v minus 1s will cancel, leaving you with 5v over negative 1, which is negative 5v. All right, so the next problem, we're going to factor the polynomial, and so the numerator does not have a GCF, so we'll factor this down into x plus 10 and minus 3. The denominator does have a GCF of 9x. Factoring that out leaves you with x plus 10. The x plus 10s will cancel out, leaving us with x minus 3 over 9x. Now remember that when you are reducing, you can only cancel factors. Factors mean things that are multiplied together. This x right here is not a factor, so it cannot cancel with the x in the denominator. X minus 3 would be able to cancel with another x minus 3, but x by itself cannot reduce because it's not a factor. Up here, these x's are factors. There's multiplication in between these, and so it was able to cancel with other factors. Okay. All right, so the next problem, in the numerator, we can factor out a GCF of 2x, which will leave us with x squared plus 8x plus 12. And the denominator will factor down to x minus 3 times x plus 2. Now this numerator right here in the parentheses can factor further, so we'll go ahead and do that. That goes down to x plus 6 times x plus 2. And then we have our denominator of x minus 3 x plus 2, and the x plus 2's will cancel out. X plus 6 will only cancel with another x plus 6. We don't have an x plus 6 down here, so we cannot cancel anything else. That is it. So therefore, 2x, x plus 6 over x minus 3, that is our reduced answer. All right, so now we're going to get into multiplication. Now, if you notice, this problem also does not have any addition or subtraction. Therefore, what we're going to do is just prime factor everything. All right, so the first one would be 5 times y times y. 9 is 3 times 3 times an x. And then 10 is 2 times 5. And so when we cancel, we can cancel a numerator with a denominator, and it does not matter if it's this fraction or this fraction. If it is in top and in bottom, we can cancel. We can cancel here, we can cancel here, but we cannot cancel if they are both in the denominator or both in the numerator. All right, so this 5 is in the numerator, this 5 is in the denominator. They will cancel out. We have 1y in the numerator, 1 in the denominator. Those will cancel out. 3's will cancel out. And so that leaves us with 3xy over 2. And that is our simplified answer. The second problem here, again, there's no addition or subtraction, so we're just going to prime factor everything. So this would be 2xxy over 3 and 3z's. 12 is 4, which is 2 times 2, times 3. You got an x, and then you got 4 z's. We have 6, which is 2 times 3, and we've got 3 y's. So the 2 in the numerator cancels with 2 in the denominator. We have a couple of x's in the numerator, but there are no x's in the denominator, so we have to leave those alone. This y will cancel with one of these. This 3 will cancel. We have 3 z's in the denominator, and that will cancel with 3 of the z's in the numerator. And I think that is about all that we have. All right, so our final answer then here is going to be a 4x cubed, got another x over here, so 4x cubed, and we've got a z. Over, and then we have 3y squared in the denominator. And that would be our simplified answer. Now with division, the only difference is we have to remember that when you divide by a fraction, you multiply by the reciprocal. All right, so that means, and this first fraction, it's not really a fraction, but we could write it as 1 by simply putting it over 1, if that helps. So this would be the same thing as saying 24e squared d to the 4th times 5f over 3c d to the 4th. Now it's just like the problems we're doing on the other page. There's no addition or subtraction in here, so we're just going to prime factor everything. 24 is 4 times 6, and that would break down to 2 times 2 times 2 times 3. Couple of e's, 4 d's, 5f. does not break down any further. And then we have 3c and then d to the fourth. All right, so all of the d's will cancel out. This 3 will cancel with this one, and that's about all that we have that'll cancel out. So we are left with 3 2's multiplied together and a 5. So that would be 8 times 5 is 40. We have a couple of e's still left and an f in the numerator. The denominator only has a c. And that is our simplified answer. Now keep in mind, I just wrote all these variables out like this as a demonstration purpose. Most of the time you're not going to do this. You would just leave it as d raised to the fourth power, and the same thing down here, and understand that you would cancel those. Because, for example, you may have a situation where you have something like c to the 25th over c to the 23rd, and you don't want to write all those out. You just know that you get 25 c's in the numerator, 23 c's in the denominator, and that would reduce to just a couple of c's that don't cancel out in the numerator. So that's how you would normally treat this. All right, so the next situation is multiplying, but this time we do have addition and subtraction in here, so we factor these as polynomials. All right, so the numerator here does not factor any further. It's just simply a minus 4. A squared minus 16 is a difference of 2 squares, so it factors to a plus 4 times a minus 4. This numerator factors down to a plus 4 times a plus 1, and a minus 5 does not factor. So now we can cancel like factors. We have an a plus 4 in the numerator and denominator. We have an a minus 4, and nothing else will cancel. We are left with a plus 1 over a minus 5. Now remember that these a's are not factors, which means they do not cancel with each other. All right, so an a plus 1 will only cancel with another a plus 1. All right, so now we're dividing with polynomials. And so in the numerator, the first thing we do is take out a GCF. We can take out a GCF of 2n squared, which will leave us with 2n minus 7. The denominator, we can also take out a 2n squared, which will leave us with 7n minus 4. We're going to change this to multiplication, and remember that we reciprocate, so the denominator becomes the numerator, and we can factor a 7 out of this, which leaves us with 4 minus 7n. And the numerator becomes the denominator, where we can factor out a 4, leaving us with 2n minus 7. Now, canceling the factors, we have 2n squared. Those will cancel out. We have a 2n minus 7 cancels with a 2n minus 7. Now, what we have left is 7 times 4 minus 7n over 4 times 7n minus 4. Now notice that these are exact opposites of each other. Whenever you have that situation, you want to factor a negative 1 out of one of them so that we can cancel those factors. It does not matter which one we factor the negative out of. So let me just do the numerator. Factoring a negative now makes it negative 7, and then the binomial becomes 7n minus 4. Now the 7n minus 4s will cancel out, leaving us with negative 7 over 4. All right, the next one, Numerator, again, start out by taking out our GCF, which is 2. That leaves us with 7x plus 5. Denominator just stays. We change this to multiplication, and we reciprocate. So the denominator becomes the numerator, or we can factor out a 6, which leaves us with 8 minus 3x. The numerator becomes the denominator. There is no GCF, so we factor this, and this factors down to 3x, 1x, let's see, 7, 8 plus minus. Now your 7x plus 5s will cancel. Once again, we see these are exact opposites of each other. So we can factor a negative out, and that would make this a negative 6 times 3x minus 8 over 3x minus 8 times x plus 7. We have a 2 left over here. The 3x minus 8s will cancel. And then that is going to leave us with negative 12 over x plus 7. I accidentally wrote this 3 outside the parentheses. It should be inside the parentheses, which would cancel out with the numerator. All right. The next problem, this is our last one. Let's save the biggest for last. So factoring the numerator goes down to 2x times 1x, and 3 and 1, everything is positive. Denominator is 2x, 1x, and then 2, 3, again, everything is positive. Change this to multiplication, and we remember to reciprocate. So the numerator becomes the denominator, which factors to x plus 5 times x plus 1. And this becomes the numerator, and we can factor a GCF of negative 5 out of this. Now, whenever you have a polynomial with an x squared, you always want the x squared to be a positive x squared. So even if you just had a negative sign here, you would want to factor a negative 1 out of each term. Okay, so in this case we have a negative 5, so we're going to factor a negative 5 out of all of these, which changes the middle term to a positive 7x and plus 10 on the end. Now, this will factor further the one that I just wrote down, so let me just write this whole thing real quick. All right, so this will factor down to x plus 5 times x plus 2. Now we start canceling factors. All right, so we have a 2x plus 3 that cancels. We have an x plus 1 that cancels. An x plus 2 cancels. And an x plus 5 cancels. The only thing that we are left with is negative 5. That is our reduced answer on this. Now, we also want to keep in mind that we will have some values that are called excluded values. Excluded values are values that would cause your denominator to be equal to 0. So in this first problem here, if you look at your denominator, we have 25x. Since you cannot divide by 0, that simply means that x cannot equal 0 for this problem. Because if x is 0, then you would be dividing by 0, and that's not possible. So 0 is an excluded value. On the next one here, the excluded value means we're, again, looking for what can x not be. Well, x cannot be 1 in this situation because, I'm sorry, not x, v. Cannot be 1 because if v is 1, then that would give you 1 minus 1, which is 0 for a denominator. All right, so that is called your excluded value. In the next problem, what you want to do is you want to look at the factored version because it's easier to pick out what x cannot be. Here we have this factor multiplied by this factor. If any factor is 0, that would cause your denominator to be 0. So that means x cannot be equal to 0 or negative 10 in this problem. Because if x is 0, that would give you 9 times 0, which is 0, and 0 times anything would be 0. And negative 10 would cause this parenthesis to be 0, and then 0 times this would be 0. So there are two values that causes this to be 0. Here the excluded values would be positive 3 and negative 2. Okay. All right, so let's jump over here to one of these. Okay. All right, let's look at this one. So in this particular problem, x cannot be a value that causes this to be 0. Now, if you have a problem with seeing it, see over here, these are easy. We know that x cannot be negative 1, because that would make this 0. X cannot be negative 5, because that would make this factor 0. X cannot be negative 2, because that would make that value 0. Now on this one, because you have a 2x plus 3, if you're trying to figure it out and you're not sure, just take the factor and set it equal to 0. So if you took 2x plus 3, set it equal to 0, and then just solve for x. Well, you would solve for x by subtracting 3 and then dividing by 2. That would make it negative 3 over 2. That's the value that would cause this to be equal to 0. So that is your excluded value. On this one, we had a 7x plus 5. So that means if you were to set this equal to 0 and then subtract 5 and then divide by 7, that would give you negative 5 sevenths. That's the value that x cannot equal. Also this one, if you set this equal to 0, you would add 8 to the other side and then divide by 3. So 8/3 is an excluded value. And then negative 7 would also cause your denominator to be 0.